Hi, this is Javin Kharod, a chemical engineer by profession, going to continue our today's topic, packed bed. Now what is that? In chemical processing, a packed bed is a hollow tube pipe or other vessel that is filled with packing material. The packing can be randomly filled with small objects like resting ring or else it can be specified design structure packing. Packed bed may also contain catalyst particle or adsorbent such as zeolite, pellet, granular activated carbon, etc. The purpose of packed bed is typically to improve contact between two phases in chemical or similar processes. Packed bed can be used in a chemical reactor, a distillation process, or a scrubber, but packed bed have also been used to store heat in chemical plant. In this case, hot gases are allowed to escape through vessel that is packed with a refractory material until packing is hot. Air or other cool gas is then fed back to plant through hot bed, thereby preheating the air or gas feed. Now its application. Pack column. In industries, pack column is a type of packed bed used to perform separation process such as absorption, stripping and distillation. A pack column is a pressure vessel that has pack section. The column uses certain type of chromatography consists tube filled with packing material can also be called pack column and their structure has similarity to pack beds. Now column structure, random and stack pack column. The column can be filled with random dump packing creating a random pack column or with structure packing section which are arranged or stacked creating a stack pack column in the column. Liquid tend to wet the surface of packing and the vapor pass across this wetted surface where mass transfer take place. Packing material can be used instead of tray to improve separation in distillation column. Packing offers the advantage of a lower pressure drop across the column when compared to plate of tray which is beneficial while operating under vacuum. Different shape packing material have different surface area and void space between the packing. Both of the factors affect packing performance. Now liquid and vapor distribution. Vapor to liquid ratio. Another factor in performance. In addition, the packing shape and surface area is liquid and vapor distribution that enter the packed bed. The number of theoretical stages required to make a given separation is calculated using a specific vapor to liquid ratio. If the liquid and vapor are not evenly distributed across the superficial tower area as it enters the packed bed, the liquid to vapor ratio will not be correct and required separation will not be achieved. The packing will appear to not the working properly. The height equivalent to a theoretical plate means HETP in as far as chemical engineering term will be greater than expected. The problem is not packing itself but the maldistribution of fluid entering the packed bed. The column can contain liquid distributor and redistributor which help to distribute the liquid evenly over the section of packing, increasing the efficiency of mass transfer. The design of the liquid distributor used to introduce feed and reflux to a packed bed is critical to making the packing perform a maximum efficiency. Now packed column vapor equilibrium curve. The packed column have a continuous vapor equilibrium curve unlike conventional tray distillation in which every tray represents a separate point of vapor liquid equilibrium. However, then modeling packed column, it is useful to compute a number of theoretical plates to deonate the separation efficiency of packed column with respect to more traditional tray. In design, the number of necessary theoretical equilibrium stage is first determined and then packing height equivalent to theoretical equilibrium stage known as height equivalent theoretical plate is also determined. The total packing height required is the number of theoretical stage multiplied by the height equivalent theoretical plate. Now packed bed reactor. The packed bed reactor can be used in chemical reaction. In chemical industries, the reactors are tubular and they are filled with solid catalyst particles, most often used to catalyze gas reaction. The chemical reaction takes place on surface of catalyst. The advantage of using packed bed reactor is higher conversion per weight of catalyst than other catalyst reactor. The conversion is based on the amount of solid catalyst rather than volume of reactor. Now, concept and theory behind packed reactor. The Ergun equation can be used to predict pressure drop along the length of packed bed given the fluid velocity, the packing size and the viscosity and density of the fluid. The Ergun equation, while reliable for system on surface of the earth, the unreliable for predicting behavior system in microgravity experiment are currently underway aboard the International Space Station to collect data, develop reliable model for in-orbit packed bed reactor. Now, monitoring packed column and bed. The performance packed bed is highly dependent on flow of material through it, which is turn depend on packing and how the flow is managed. Electrical tomography may be used to observe the distribution of liquid at different cross-section vessels or intended flow pattern throughout the packed column. Depending on nature of material, capacitance, resistance, tomography may be used. Packed column are used. Distillation, gas absorption, liquid-liquid extractions. The gas-liquid contact in a packed column is continuous, not stage-wise as in plate column. The liquid flow down in the column over the packing surface and the vapor or gas move countercurrently up the column. Now, why packed column used in distillation? The column structure random and stacked packed column packing material can be used instead of tray to improve separation in distillation column. Packing offers advantage lower pressure drop across the column when compared to plate or tray, which is beneficial while operating under vacuum. What is meant by packed column? You may be asking yourself, what is packed column? The packed column is a pipe or hollow tube filled with fine particles and packing material. You can think them the pressure vessel. The packed section include final design. They are usually cylindrical and shorter than capillary column. What are advantage and disadvantage of packed column? The column is good for thermally sensitive fluid and suitable for low pressure operation. The disadvantage are packing can break during the setup due to thermal expansion. Packed column aren't cost effective for high liquid flow rate. Where packed column is used? Packed column are used for liquid extraction, distillation, gas absorptions and liquid only distillation and absorption will be considered in these sections. What are packed column used for? Packed column are used distillation, gas absorption, liquid-liquid extraction. The gas-liquid contact in a packed column is continuous, not a stage-wise. As in plate column, the liquid flow down in the column over a packing surface and the vapor or gas move countercurrently up to the column. The packing type, they are pole rings, resting ring, saddle. Material are usually plastic or ceramic. Packing height should be limited about 6 meters. For greater packing height, 2 or more tower in series should be considered. What is packing material in column? The column packing material stationary phase is often silica based with bonded phase attached such as long hydrocarbon chain C18 to C8 or phenyl or cyano group or produce the hydrophobic reaction retention. What is packing material of distillation column? Standard distillation column packing, a range of packing type for fractional column is available. The standard distillation column packing offered is random packing, means packing can be used including material stainless steel, metal alloy, ceramic and plastic. Okay guys, this is up to a brief introduction about packed column and packed bed reactor. I hope you get sufficient knowledge after watching this video. Next chapter we have covered some another chemical engineering topic. Till then, goodbye. Do take good care of yourself.